All right, let's look. Okay, now we have already done this. We have already done this. Okay, but we have already done this, but we were looking at other types of equations. Specifically, we did this with absolute value equations, right? So like if we had the example that we would have looked like this. We would have had like y equals the absolute value of x plus 2. You guys remember doing that? What did the plus 2 do in this case? It would move it up 2, right? The same thing happens with an exponential or a log, okay? It takes whatever the exponential graph was, it moves it up or down. So for an exponential example, it might look like this. Y equals 3 to the x power plus 2. Okay, it will not be in the exponent. In exponential examples, the parentheses or the bars that we would see, they're like up there in the exponent. Okay, for log examples, it would look like this. Y equals log base anything 4 of x plus 2. That plus 2 is not in the parentheses. There's understood parentheses right here. Okay, so both of those would be examples where this would just move the graph up 2. Okay. All right, so those are vertical translations. That's our up or down. Let's look at horizontal translations. Okay. Horizontal translations are left and right, and they go in the opposite direction of the sign. So we've already done this once with absolute value. If I had something like this, y equals the absolute value of x minus 5, what would that do? That would be right 5. Okay, so the exponential is the same. It just looks a little bit different because it's a different formula that you're starting with. So it would look like this for exponential. You might have, it could be any base. Let's use a 7. And you would have x minus 5 up here, the whole thing in the exponent. So there's not parentheses written there, but it's like whatever your exponent is in the parentheses. That would move the 7 to the x, 5 to the right. Okay? For the logarithmic example, it would look like this. Y equals log. Base could be anything. It doesn't matter. I think I'll just use the common log here. X minus 5, and that minus 5 would be in the parentheses. So for logs, your parentheses are like our bars were for absolute value. For exponentials, your exponent is like the bars were for our absolute value. Okay. Moving on. We did not do a lot with vertical dilations, but we did have a few that looked like this. So this was where we had maybe like 3 times the absolute value of x. Okay. If this number right here, this is incorrect too. Let's fix this. That should say if a is greater than 1. So if you multiply your equation by a number bigger than 1, it's going to stretch it out vertically. It's going to make it look like taller and skinnier. If you multiply it by a number between 0 and 1, so like 0.5 or 0.2 or 1/10 or something like that, it's going to squish it down and make it shorter and fatter. We mostly just relied on Desmos for being able to tell how that happens because it's a little harder to picture. But what this looks like for exponentials would be like this. Y equals 3 times 2 to the x power. Okay, so you got a number multiplied by some number to the x power. This one is the one that like gives kids trouble. It's hard to recognize. It's hard to separate the base from the number that it's stretching or shrinking. But we also are allowed to use Desmos on everything. So when you're unsure, type it into Desmos and match up your points for that. For the log example, it would look like this. 3, let's use a natural log of x, like that. Okay? And then the last thing that we did for our transformations is we reflected over the x-axis. This is your flip upside down, right? So for the absolute value ones, it looks like this. Y equals negative absolute value of x. For exponentials, it will look like this. Y equals negative, and then whatever your base is, 5 to the x power. For log examples, it will look like this. Negative log, your base could be anything, of x. So all those rules that we learned for absolute values are the same for exponentials and logs. Okay? So let's look at some problems here. Okay, so for each one of these, we are supposed to tell the parent graph and describe each transformation. Okay? So, if it is an exponential, you are looking for the number raised to the power. This part right here is not a transformation. That 2 doesn't do anything to the graph. That's your parent function. Okay? So, the parent function here would be y equals 2 to the x power. That's the exponential that you're starting with for these. Then you have to tell about the transformation. So anything besides 2 to the x causes a transformation. In this case, we got a plus 7. What is that going to do to the graph? It's not going to stretch it. What is it, Maya? How many? Up 7. Okay? So the adding or subtracting on the end here moves it up or down. Okay? Let's skip down to example 3 because that's our other exponential. E is being raised to the power. So that e to the x, that's your parent function. Y equals e to the x. Okay, now in this case, we got 2 things that are happening. They don't put parentheses around the exponent, but I'm going to. We got the minus 4, and we got the plus 5. So, Lily, what's the minus 4 going to do to this graph? Yes, it is going to move it to the right 4. So whatever is on the inside of the parentheses moves it left or right. Okay? Jeremy, what's the plus 5 going to do to the graph? Okay? Up 5. So if it's out here on the end, not in the exponent, that moves it up or down. Okay? Dodge that one. All right. Let's go back to the log. Okay? So for the log one, the parent function would just be y equals log of x. So that's this part right here. We have a minus 3 right there. So, Scarlett, what's the minus 3 going to do to our graph here? It's going to move it left or right. 3 units. Which one is it going to be, left or right? It's to the right. Because on the inside of the parentheses or the bars or whatever you've got for the problem, it's going to move the opposite direction. So it's going to be right 3 for that one. Okay, questions? Okay. All right, you're going to get a lot of these in multiple choice form. All right, this says, Now let's try to do it without Desmos, and then let's go look at Desmos to check, okay? We got natural log of x plus 2 minus 3. What does this plus 2 do to the graph, Angel? Left 2. Okay? Victor, what does the minus 3 do to the graph? What? It does. Which, it's going to move it up, down, left, right. Which way does it go? Down 3. So that number on the end moves it down 3. So, a natural log usually looks like this before you move it, right? It's going to have a vertical asymptote right there at the y-axis. We need to go left 2, down 3. Which one do you think is correct?
C.
It's C. All right, now, what I want you to do, though, especially if you are struggling on this, type it into Desmos to make sure you are right on these problems. So if I go over here, all right, I've got f of x equals natural log of x plus 2 minus 3. You can tell, now maybe you're having some trouble deciding. A and C look kind of similar to you. Find some actual points on the graph, like right here. That point's like 5, negative 1. This one goes through 5, negative 1. This one does not go through 5, negative 1. Like, match some actual points, right? But use that, because how you are zoomed in or out can affect how it looks. So, like, if I zoom way out here, it might be hard to tell on that. Okay, questions? All right. Okay. Next problem. I want everybody to try it without Desmos. Try it without Desmos. And then use Desmos. Parent function on this would be y equals 3 to the x. You'd start with this. Actually, it might be y equals 2 to the x. Could be. All right. Anybody got it? Anybody think they know? One of these I would rule out right away. I'd rule out B right away because I know that went up. B here went up 2. And, like, this has a horizontal asymptote at negative 2. It's moved down, right? So, I would throw out B right away. Which one do you guys think, A or C? Okay. Which direction does this go with that plus 3? That's left 3. But on this, always check yourself with Desmos to make sure that you are right. And that looks different, definitely because of the way I'm zoomed, but you can always kind of look at some points, look at the asymptote. Like that goes through negative 2, 1. Negative 2, 1 is right there. So you can see. Okay? Alright. This one, we can graph it, but this one's a lot easier if you just know your rules. Which function is the graph of y equals log x that has been translated to the right 4 units? Okay? It's going to be C for that one. Because you got the minus 4 on the inside, it goes the opposite direction. Okay? You can always graph it to check. Graph y equals log x. And y equals log of x minus 4. And you can see there that the green graph is log x, the purple has been moved over 4. Okay? Question? All right, how about this one? A. All right, I'm going to graph y equals natural log of x. It looks similar, but let's look at some things. Like right here, like this goes through the point. I know these aren't like perfect points, but for example, 5 right there. This is like, that's the point like 3.5, 5. On this graph, let me make this full screen so we can see it. 3.5, 5. No, 5 would be up here, right? 3.5, 5. Is that on this graph? It is not. So while it's got the same shape, I don't think it is A. Okay? That leaves B or C. If I put the 4 right here, let's see, like 3.5, it crosses 5. Now look right here. That's about 3.5, 5, right? That looks better. I think it's probably this one. Let's check the last one to see. If I just do a +4 at 5, that's not really like 3.5. That's sort of just moving it up. This was like stretched it out. So for that one, oh, where am I at? That one would be B. Okay, so don't just look at it really quickly, especially on ones like this where you got that option where it's been stretched out, because those are hard to tell. Okay? All right. I want y'all to try this one on your own. Try it. Okay? Try this one. Try it right now. Everybody, type it into Desmos. See what happens. Try this one. See if you guys can get it. Different letters thrown around here. Talk to your neighbor. See if you guys can agree on what you think it should be. I don't think you'll need y equals x plus b on this one.
What do you think it is?
Well, I know what it is. I'm interested to see what you think it is. I'm not telling right now. I'm not telling.
Can I get like one hit?
I'm not telling.
One hit, is it A or not A?
I can't tell you. I can't tell you.
What about C?
It is one of these 4 answer choices. All right. Okay. All right. What do you guys think? How many of you think A? Nobody thinks A. Okay. How about B? I heard some of you saying B. Did you guys talk yourself out of B? How about C? A few of you are not very confidently saying C. How about D? Okay, I got a few that think it might be D. Okay, let's look at it. All right, I'm gonna type these in. F of x equals 2 to the x plus 3 minus 5. 2 to the x plus 3 minus 5. And f of x equals 2 to the x plus 3 plus 3. Okay. All right. Okay. For this, all right, actually I shouldn't call it F, I should call this one G, I guess. The black graph is my F function, my red graph is my G function. Which one's the one I'm starting with? Because that's the difference between C and D, which one I start with. Which one do I start with? F, because it says here, F is shifted down, or F is shifted up, or F is shifted. So we're talking about F, so the black graph is the original graph. What direction are you shifting it to get the red graph? It's going up, right? And the asymptote's the easiest thing to look at. So like right here, this is at -5, and up here it's at 3. So it went from -5 up to +3. That's going to be 8 units for that. So, answer is C. Answer is C. If you picked C, you were correct. You were correct. If you picked D, you were mixed up. You looked at the red one like it was being moved down. Why would a person pick A? F of x itself has just been like shifted down 5, right? But F is our starting point. And why would a person pick B? For B, this has been moved up 3. Okay? All right. Okay. Does this see it? That's our last. Oh, this is our last one. Okay. The function is transformed to produce the graph below. Which transformation took place? Okay? Quiet, please. We got this last one. All right. So I've got f of x equals log of x minus 2. That graph looks like this. Okay? It's transformed to produce this graph. Now, I can't type that one in because they didn't give me the equation. Okay? But I'm starting with this blue graph. Where is the vertical asymptote on that blue graph? It's at 2, right? So if I typed in x equals 2, that'd be my vertical asymptote. Where's the vertical asymptote on this graph? -4. What has happened? If we start with this graph, end up with this one, what's happened? Left 6 units. So D would be your answer for that one. Okay? All right, questions? All right. Okay. This should be able to be done very quickly. Just got 10 questions. It is your homework if you don't get it done. But I know we've only got 7 minutes, but I think you can get it done. Okay. The front is matching. The back is multiple choice.
Oh my God, I don't know what I'm doing.
All right.
I need help.
Okay. Angel